So what's the purpose of a load test in the first place? Why do we perform a load test against our endpoints and against our applications? What we're ultimately trying to help our customers understand is how well their applications perform under some degree of concurrency. So as more and more people are interacting with a website at the same time, what happens to the application's performance? So as you can see in the graph here, as a perfectly viable and common output of a load test, as I increase the number of users interacting with my application, the blue line, you can see that performance of the application, the beige line, degrades a little bit as we increase the user count. And then at some point in time, we have a significant number of errors, the red line, and performance goes to 0. So again, this could be a perfect example of a case where an application doesn't scale properly, crashes under load, and can help us understand things like what the breaking point of my application might be. If it doesn't scale properly, can it handle expected load? These are the kinds of questions we're ultimately trying to answer with a load test. So we do that with a couple of components inside of the NeoLoad platform. First and foremost, we have something we call a controller. This is essentially the scripting engine. So all load testing tools require the performance engineer create some kind of script which models the user activity that we want to include as part of a load test. So as an example here, we'll create a new script, as you can see, using the NeoLoad recorder, where I now can very easily, I being the performance engineer, the business analyst, anybody, can navigate through the application that I want to test and capture an end user path, a script, a user path, whatever the term might be. It's ultimately going to be a path through the application. But unlike a functional tool, a load testing recorder is not concerned so much with what's going on inside the browser. Instead, it's actually capturing the network traffic that we then want to bombard the application under test with later. So as I walk through the recorder here, I can break up my script into meaningful components called transactions to make my scripts more readable and more maintainable and more portable, etc. So I'll complete this recording here, adding a couple different transactions. This is a sample insurance application I'm writing a script against. And then I'll complete the recording process. So NeoLoad is capturing all that information now, and it is now turning that information into something we call a user path. A user path is our term for a script inside of NeoLoad, and you'll see that we've got a number of really cool mechanisms that make script creation and script maintenance significantly easier than other tools in the market. Productivity is our bread and butter. We're not changing what a load testing engineer has to do. We're making it significantly easier. And one of those places is in the scripting engine. So for those of you who have seen load testing scripts in other tools before, you know they're always text-based. NeoLoad scripts are all these nodes you see in a tree view here that make A, learning NeoLoad significantly easier compared to other tools that we compete against, but B, beyond that, significantly more productive in terms of the amount of time spent to create, customize, and then maintain scripts. And we'll look at some of that in a couple moments here. Another way we can create scripts is with the integration that we have with Tosca, the Tricentis functional tool. So we have a plugin that allows one to take a Tosca script and convert it to a NeoLoad script by transferring this ability here. So as I launch this transfer functionality inside of Tosca, what's ultimately going to happen now is Tosca is going to run its test case as it normally would, but at the same time, it pokes NeoLoad under the covers and says, hey, NeoLoad, I want you to launch your recorder and capture the traffic that is being generated by the browser as I'm doing this recording process. And then at the end of that process, we'll end up with a NeoLoad script. So I'm automating what you saw me do manually a couple of moments ago, but I'm able to now reuse assets I've already built on the functional side and not have to build those all over again. So you see I now have a new script in NeoLoad that was created based on what we captured from over on the functional side over from Tosca. Once I have my scripts recorded, I do need to do some kind of customization. We want to make sure our scripts are customized so that when I run a load test with a number of concurrent users, my behavior is realistic. Not every single person is going to log into the application under test with the same credentials or do the same thing the same number of times or perform, look up the same number of items and add to a shopping cart, anything, right? So we can parameterize and customize these scripts very easily as we would in any load testing tool, but we do this again much more productively just by dragging and dropping loops and branches of conditions into my script by parameterizing data in forms with a couple of mouse clicks to create variables. I don't need to write any code. That's the most important thing here to understand is other tools would require an engineer to be in a text editor, banging on a keyboard, fighting a syntax compiler, which is a significantly more error-prone and a significantly less productive way to do these activities. So you see in NeoLoad, we've got a very nice number of wizards that allow me to create variables of many different shapes and sizes to be able to load into a script, all about parameterizing my script so that when I run a load test, the application that I'm testing will think that there are different people interacting with it at the same time doing different things. That's real world behavior. That's what we want to model as part of a load test. So you can see an example here. I can very easily parameterize a username and password just by walking through a wizard using some of the variables I created a couple of moments ago. Super easy to build all this kind of stuff. I cannot stress the importance of the limitation of the script-based tools compared to what's going on our side without having to write any kind of code. Once my scripts are created, it's then defining the load test itself. Very easily done through the GUI that we've got here, and you can see we can tell NeoLoad's platform which project I want to use, how many concurrent users I want to emulate, how long my test is going to run for, and then where my infrastructure is. So where my execution engine is going to be, where the load generation mechanism is going to be. This will all be done dynamically. Another key advantage of NeoLoad is I do not require the organization to set up a static load testing infrastructure, which is the way that we've been doing this in the space for decades. Instead, we can use modern orchestration technologies, Kubernetes, and things of that nature to be able to build the load testing platform on the fly while the test is running. And I'm kicking off a test right now, as you can see, and NeoLoad is going to run around and poke Kubernetes in this case and create controllers and execution engines and load generators all automatically. This significantly more productive than static infrastructure. It's less costly, it's easier to maintain, and it allows my organization to be far more productive as well. I don't have a number of performance engineers fighting over static infrastructure. Common situation, I want to run a test on Tuesday, but I can't because Bobby's running the test at the same time. That all goes away with our dynamic ability. We can also build logic into our load test as well. So it's not just old-fashioned, what's the performance, what's the round-trip time that we typically have measured in load testing tools, but instead we can add service level agreements or SLOs or other kinds of thresholds that determine whether or not a load test passes or fails based on business requirements. So in this case, you can see I'm tying a threshold to my login transaction. And I want to be told, I being the performance engineer, whether or not that transaction is slower than 4 seconds while the test is running. And so you can see from some results that I have run earlier, I have the ability to indicate whether a test has passed or failed based on the SLA that I defined. It's not so much whether the application crashes or not, but it might just be slower than I want it to be, and I want that to be marked as a failure as well. And so building that intelligence into my test is another key feature of NeoLoad that allows me to far better collaborate across the enterprise with other stakeholders that are part of the SDLC. You can see the test that we launched earlier is now off and running. And so being able to view data in real time by anybody that's part of the conversation, whether it's a developer, a performance engineer, an application owner, a DevOps engineer, an SRE, anybody can log into the web component and be able to watch the results of a test in progress or look at data from tests run earlier. So collaboration across team members, another really key important part of the testing environment here. Now, if a test fails, as you can see here, we can also log this information back into the test management solution. So in this case, we have an SLA that failed because my update billing transaction took over 4 seconds, which was the threshold that I defined. And so it was marked as a failure, i.e. this load test fails. And so we could actually not just have this information centralized to the performance engineering team, but we can propagate this back out to the test management solution. So you'll see that we mark this as a Q-test entry. And by clicking on the link inside of NeoLoad, that will take me over to Q-test, show me the results of this load test as it's being run over time, as well as the results. So the management side of the house can now get a sense of coverage from a testing standpoint on the load and performance testing side, as well as results from their dashboarding. So you can see I've got a test here that failed as measured by the SLA. We log it as a bug, which could then be logged with your favorite bug tracking tool through the Q-test integration with all the appropriate information that comes out of NeoLoad back to our side as well. And then we can go the other way. So from within Q-test, we have a link as part of the result set. So you can see the data of the result actually here specifically, where the failure is, what the measured value, what the actual value was, etc. And then here's the link I was referring to, right? So you can take this link and click on it, and it will take you right back into the NeoLoad dashboard and show you the results from the NeoLoad point of view as what was marked on the test management solution. And then you can see performance from a user concurrency level, and then indicate the or investigate the actual SLA as was defined here that we looked at a little bit earlier. We can also look at result trends. So if we're doing continuous testing of any kind, we want to probably be able to understand how the performance of this application that we just tested compared to a test that I ran earlier. If I'm doing multiple releases or very frequent load tests, I want to probably get a better understanding of how my application is trending. Have I introduced any performance degradation with a new release or a bug fix or an update? And so being able to use the dashboards that are built into NeoLoad will allow me to get a sense of that very easily, very cleanly as part of this dashboarding here.